Thank you everyone for being with us today. And I hope you are having an exciting day today. I have one of the most exciting topic which I'm going to talk about, which is all about quantifying your world with AI and Docker on the edge. So let us get started. Okay, a little about myself. I am a blogger at Collabnix. Collabnix is my personal blogging site, and I have been writing since last 5 years, 5 to 6 years. I have around 200 plus blogs which I have written around Docker, Kubernetes, and cloud. So do visit it. You might find it useful. I'm also a Docker captain. Right now, I'm working as a developer relations manager at Redis Labs, where I'm helping Redis developers with the contents, more and more contents around the Redis enterprise as well as open source. I'm also a Docker Bangalore community leader. We have around 10,200 plus community members in Docker Bangalore meetup group. And we have been conducting meetup all across India, especially doing it as a virtual conference. I'm also a part of ARM Innovator, which means that I work very closely with other 50 plus ARM innovators and try to see how we can go ahead and contribute in terms of AI, Docker, and edge devices. I worked in the past with the companies like Dell, VMware, and CGI. Okay, so today agenda would be roughly something which rotates around AI plus Docker plus IoT. So I will start my session with talking about benefits of containers for AI adopters, because since AI is a computer science branch which talks about how you can build a smart machines using a human intelligence, right? So, but why containers? Why we are talking about containers here? Why we are talking about IoT here, right? And what is the relationship in between containers, AI, and IoT? And then I will talk about a few of the very interesting facts around the newly launched Jetson Nano 2G board, which cost around $59. So I am going to talk about its deep learning stack, GPU support under Docker 1903. If you are quite new to the Docker, this would be interesting for you. One of the interesting tool which I have been exploring and I have been contributing directly and indirectly is Open Data Camp. So I will show you a cool demo around it. And then I have two demos to showcase how the deep learning, AI, Docker, IoT comes into the picture and how you can build an exciting projects around it. So this agenda will definitely be, it will excite the audience, especially the college students as well as the DevOps engineers who wants to pursue their career in cloud native application on top of IoT platform. Okay, so what AI plus Docker plus IoT has to do here? So let's cover the first two parts, AI and Docker. Benefits of containers for AI adapters. So let me take you to one of the report from 451 Research. So this is basically this year they went ahead and did a kind of a research across how the containers have been used for the AI platform. You will be surprised to know that around 94% of AI adopters are planning to use containers. Now, this is something really amazing because containers has been there for some time, right? There are container workloads, but think of CI/CD platform running on our IoT devices like Raspberry Pi, right? That sounds really interesting. The more interesting fact here is all of those factors: increased portability, easier management, improved resiliency, developers productivity, faster time to deploy. These are the reasons, right? These are the reasons why we are talking about containers on IoT. If you look at Docker as a platform, Docker is an open platform which helps you to build, ship, run and share your workloads, right, in the form of the packages. And that packages, no matter if it is a bare metal or on the cloud or an IoT device, right, that packages from your development to the production has to accelerate the whole software life cycle development, right? So we are talking about a DevOps model. So these are basically the factors, and based on the survey, what they found that, is if you look, 14% believe that containers can be used on IoT devices or can be used for AI for the faster time to deployment. So these were the facts which which I thought about, and then I thought that, okay, let's come up with something exciting around it. Now let's talk about AI and IoT, right? Why should I really care about IoT? Now let's go back and try to see, try to look at the connected devices per person. Okay, if you look at the world population at this point of time, we are at 7.8 billion, right? That's used. And then in next 4 years, we will be crossing 8.1 billion. Now let's look at the connected devices. In connected devices, right? At this point of time, we have it's not a billion, it's 8.8 connected devices, right? Which will be having per person. Like the connected devices in terms of per person, it will be 8.0. So which means that at one point of time, you will have 8 devices with you, like a mobile phone or in the form of the smartwatch, right? These are the connected devices which you will be having, right? And that could be a medical equipments also, which you carry all the time, right? So those devices are going to surpass the world population. Look at the connected devices as 13.5 billion connected devices you will have by 2024. So that's the reason why we are talking about IoT. That's the reason why we are talking about how the uh, DevOps model or CI/CD model or faster time to market, right? So to enable the faster time to market, why we need those devices to run our workloads. Now, if you look at IoT infrastructure, especially the IoT boards, at this point of time, we have these popular boards like Raspberry Pi, uh, NVIDIA Jetson, so, and then Banana Pi, Arduino, Orange Pi, right? So these are very tiny devices, like a credit card size, where you can run your workloads. And these workloads could be an AI workloads or any kind of a workloads which you think can collect the information from your site. If you are a farmer, you can use the device to know the moisture of the soil. Based on that, you can go ahead and do the cropping part, right? If you are the person of, if you are an authority which wants to track the traffic signal, you can have these devices installed on the traffic signal to see which vehicles are following the rules or not. So there are multiple use cases which comes in between. And one of the device which I was really excited about, and this was launched just 3 to 4 days back, was Jetson Nano 2GB. So these are the devices which cost around $59. And one of the exciting features which these devices brings is the GPU. So you now have a GPU card inbuilt into these devices, which means that you can run any kind of a uh, deep learning workload on top of it. Look at the specifications. These specification, if you look at the specs, it very well matches with what you have in your mobile devices or you have on a server. Especially 128 core NVIDIA Maxwell. This is a GPU device where you can go ahead and train your deep learning model. That is something, because CPU alone can't do it, right? You need a more and more processing which has to be done, and GPU does that. With 4GB, you have especially the 4GB memory, but with this 2GB model, you just have a 2GB 64-bit LP DDR, and then it comes with, it is basically a kind of a laptop. It has USB port, it has HDMI port for your display. You can connect any wireless dongle to it and then start working on it. And it comes with a Linux distribution as well as Windows IoT, which you can run on top of it, right? And these, all the operating system, like whatever the operating system you want to run, runs on the micro SD card. Now look at the way how you have been using these kind of a devices for running an AI workload. Now, if you look at the stack which is provides, especially I'm talking about NVIDIA Jetson here, because this is one of the device which is quite exciting for me. If you compare to the Raspberry Pi, which doesn't come with a GPU, right, in the 2 GB model, but in this, you have a very strong CUDA stack, right? The CUDA stack is for the parallel processing. For a deep learning or AI model, you need such kind of, powerful devices. And CUDA is one of the parallel computing, you know, uh, CUDA provides you with the parallel processing altogether. And look at the modules which you use. OpenCV is one of the computer vision model, which is free of cost, or it is open source. You can go ahead and use it. TensorRT is one of the AI module, which you can go ahead and integrate with a lot of AI workloads. OpenGL, Video API. So these devices basically comes with a Jetpack, which has all the necessary stuff which you need to implement a deep learning platform. And that is the reason you don't have to spend more and more time in building your own deep learning model. These models come shipped with these devices, and you can go ahead and get started with it. And then you have a gesture recognition, object detection, analytics. And during the course of time, at the end of this presentation, I will show you how you can go ahead and do a deep learning based on these kind of devices. Okay, so what happened when AI, Docker, and IoT come together? So now this is an exciting part, and I'm going to, I'm sure you will definitely like this. Okay, I'm going to introduce a kind of a tool called as Open Data Camp. So if you have a Jetson Nano with you, this is a tool which is basically ready to go tool. You just install it in terms of Docker containers, and that's it. So let's talk about Open Data Camp. Now, Open Data Camp is basically a GitHub repo. If you go to github.com/opendatacamp/opendatacamp, you can see the whole description, which is written in very nice way, and the detail. And uh, so basically it is a 100% open source solution which you can use it. It quantifies and tracks the moving objects. As I said, right, AI is that branch of computer science which helps you to build a smart services. And this is one way where you can go ahead and even build self-driving cars. So this could be one of the solution which you can use, especially the payload. I am working in one of the project called CherryBot, which is a self-driving robotic platform. So most probably these kind of solution will definitely help you in tracking the objects and making the machines more intelligent, where you can do whatever you have been doing, right? You can make machines work in the same way. And it runs only on Linux platform. Since Linux is very popular and it is robust, right? You can go ahead and scale it. So that is the reason you have one more benefit of running Linux and CUDA GPU. So you don't have to build something from scratch. The other thing is Open Data Camp supports Docker container as well as K3s. So if you want to run an Open Data Camp on Kubernetes platform, you can still do that. So usually we don't run a full-fledged Kubernetes on IoT device. We have a very tiny version of Kubernetes called as K3s. Okay, so infrastructure setup for my demo would be more like an NVIDIA Jetson Nano, a kind of a webcam Logitech, right? So for this demo, I picked up one of the file which I am going to insert into it, and I will show you like how easy it is to just, if you have a video, you just put it in the browser and the deep learning, you can get started with the deep learning. So, and that can be accessed through your smartphone. So what makes Open Data Camp so robust? It is basically a GPU support under Docker 1903. Since the Open Data Camp runs on Docker, or you can run it without Docker also. But if you want to get started in just 5 minutes, you can go ahead, you can pull the Docker image and get started. And 1 year back, I raised an issue about Docker Compose support for NVIDIA Jetson. Like, if you are running a container, it is okay. But if you want to use a Docker Compose, then most probably you need to basically install an NVIDIA runtime container on top of it. So there is a workaround for it. So this is one of the bug which one of the issues which I raised, and it has already crossed around 150 plus comments. But I'm happy that right now we have some kind of a workaround around it. Okay, so if you see this particular command, Docker run --GPUs all, That's it. You need just this option to basically leverage your GPU. So whenever you run any Docker container, right, there has to be some kind of a workload. So for OpenDataCam or NVIDIA SMI is the command which helps you give all the NVIDIA GPU information from your system. So you can just pass -FN GPUs and that's it. You can go ahead and there is an option where if you have more than two GPU card, you can just go ahead and specify, okay, I need only two of the GPU card to be leveraged. And the same command runs over the cloud itself. When you create an instance with a GPU, you can run the same command and you can expect the same kind of a performance coming out of it. Now, how shall I run OpenDataCam? What are the options I need to take care? So first thing is you need to make changes in daemon.json file, which is under etc docker. And then you have to specify this runtime. Just yesterday, I came to know that you don't need to do this with the latest Docker Compose version, which is 1.27. This comes by default. This feature comes by default. So I really need to go back and check this. But at this point of time, if you are using earlier version than 1.27, right, you just have to go ahead and make this entry and don't forget to restart the Docker, because daemon.json gets reflected only after the restart. And then ensure that you have NVIDIA container runtime package to be installed, and that's it. You just clone the repo and try to run install opendatacam.sh and platform nano. So let me show you a quick demo around it. So okay, so what I have done here is I have a quick recorded demo. So I will go through it so that I can get some time in showing you. So at this point of time, if you see, I am on Jetson Nano board. You can see here the architecture of this particular system. I have Docker 1903.06 running on the system. So right now we have 1903.12, but it should work because GPU support is starting from 1903 version. So we are good with this. So what I have done is I have cloned the OpenDataCam repo. So what you see here is basically OpenDataCam repository. Under that, we have a Docker, and this is a specific script which will bring up all the containers. At this point of time, OpenDataCam is supported on Nano, Xavier, and TX2 model of NVIDIA Jetson board. And these scripts all talk about, it uses a Docker Compose in between, and then it try to bring up all the microservices. So if you are new to Docker Compose is a tool which helps you to build the microservices. And you can also use Kubernetes, right? If you want to run on top of Kubernetes, you can run it as in terms of pods. So let us go started. Let us start this particular script and specify the platform. So we have a platform called Nano, and just wait for, yeah. So you don't really have to wait a long time here. So if you go to this particular link, you can see here that OpenDataCam initializes. So behind the scene, it basically uses the MongoDB and then the YOLO framework. So YOLO is a framework which basically, with the help of OpenCV, it helps to go ahead and you can do a kind of an object detection analytics implementation on top of it. And within few seconds, you will see that you will start seeing that YOLO gets initiated. And there is a video file which I have inserted into it, which is basically a kind of a the traffic, right? And you can see here how your OpenDataCam recognizes the objects as car. Whatever the percentage you are seeing is basically the accuracy and the probability. So OpenDataCam also try to classify the objects. So you can see whether it is a car or it is a person. Now, one of the really fascinating features which OpenDataCam comes with is you can set up the direction. So say now the vehicles are staying at the traffic signal, and I'm just trying to see how many devices or how many vehicles crosses this particular path. So if you see here in this traffic signal, I have till now 5 of the vehicles which has crossed. And also I can see how many how many other vehicles, other type of vehicles are crossing it. If it is a truck, so at this point of time, we just have 14 cars which have crossed it, with no person, no bicycles or any other type of vehicles. So based on that, I can stop it anywhere and try to reset the direction. Whole of this information can be stored in the form of the JSON, and that is something you can store it in database for further analysis. But look at the objects. Right now there has been around 230 plus objects which has been tracked, and I can go ahead and make the changes in terms of the counter. This is a path finder which shows you like which is an optimal path for a vehicle to travel, right? So you can see here the traffic light is on, and the left side vehicles are now moving. So you can see that the pathfinder automatically gets added to it. Okay, now this is interesting. Let me show you next interesting stuff here with one of the other demo which I wanted to show you here is whatever I posted yesterday over the YouTube if you are in the Slack channel. So take an example, what you can do with it. Yes, object detection analytics is good. You are able to track, but what about the self-driving car? Now, this is one of the video which was uploaded some times back, where through the deep learning platform, you can go ahead and operate uh, you can enable a solution like self-driving car. So at this point of time, a person is looking at the mobile and is tracking. He's setting up the destination here, and you can see a lot of box here which is basically specifying. If you look it closely, one of the truck is coming in front, so it has detected it as a truck. Using a counter, I can set it up like how many vehicles I can see, I can track, and based on that, the vehicle can move without any obstacle. So at this point of time, if you see here, I have made it as a bidirectional, which means all the vehicles moving to and fro, which is moving from uh, in your front, which is coming towards you or far from you, you can track that. So at this point of time, it is able to detect the 6 of car which are standing in the traffic signal, and now the vehicle starts here. So you can see here, uh, we are not controlling the steering. It is controlled by itself, and based on the deep learning platform, it is looking at the obstacles, how the vehicle is moving, right? Now look at the way the objects have been detected here, and based on that you can count how many objects are there. So it might have detected one of the bicycles which you see on the right hand side. Most probably based on that, it is the vehicle is getting controlled. Okay. um, the data which you collect here, right, that can be used for a lot of analytics works for sure, in order to see, like, look at the counter, look at the objects it is detecting at this point of time. There are 2 bicycles which it has detected. And especially when you see these devices, right, uh, these devices have some kind of a probability stuff, like it might detect it as 90 or 95% of it, because the model is getting trained by itself. The next time it sees bicycle, maybe the first time it will be like 75%, the next time it would cross around 90%. So you can see a diversified objects in front, and based on that, the vehicle is being controlled. And you can also see in the console like how the messages, how the YOLO is doing that, because the whole idea is, there will be one of the session which I'm going to talk about, Redis AI, which what it does is basically there is a tensor data types, right? And these all images which is being captured by the camera, which is connected on NVIDIA Jetson, it is capturing it, and it converts in the form of tensors, which are like a 2 by 2 or 3 by 3 matrices. And based on that, you can build your own model. So maybe in the near future, I am going to deep dive into it, and then most probably help you understand like how you can build your own model out of it. Look at the pathfinder. It has like whatever the turns which you have, what is the optimal path which you have, it is basically going ahead and trying to identify it. Okay, now this sounds good. Let me go back. Okay, so if you want to learn more about Open Data Camp, so I can show you basically the GitHub repo here. So this is a GitHub repo where it shows about how you can go ahead and quantify the world. And there are a couple of examples which you can see here. Basically, it is targeted for the NVIDIA products, but if you have any other device with a GPU, it will surely work. And you can see here the software prerequisite for it. So ensure that you follow all of these things. If you open this, one of the issues which I raised, which I was talking about, is NVIDIA. So this is one of the issue which I raised, and there has been around about, you can see here, 153 comments. I am working very closely with the Docker team to see how I can go ahead and have this particular feature enabled. And we really need to go ahead and put it in the release note. But look at the comments here. And if you go to, there has been a few other comments on how you run on EC2 also, right, which requires a GPU. So do look into this particular issue, we'll get to know. And these are the steps which you need to follow here. Even if you want to run it for a multiple platform, you can run it. And if you have a Pine 64 laptop, which is around $200, which comes with the ARM architecture, you can also go ahead and install it. Especially on the Kubernetes side, you can use K3s. You just install K3s. So you don't have any dependencies here. You just run this particular command and the Kubernetes get installed on your IoT device. You can try it on Raspberry Pi too, but you won't be able to leverage uh, GPU on top of it. So if you have a USB camera which is connected, you can always go ahead and use this particular, you can activate this directory dev video, and that should be helpful for you. And these devices works over a Wi-Fi. You can always go ahead and try to check this particular, and we do have an API documentation also. So I think I am pretty much done. Is there any question?